All right, so now we're going to talk about practice 12.2. This is about inference about two means in dependent samples. It's also called the paired difference. So when I was making this, when I read the title, I was like, I'm sorry, what? We're learning about what? It didn't make any sense. But as soon as I read the first little piece of information, it made a whole bunch more sense. So I want you guys to hold on with me here for a second. The paired difference design is frequently used in experiments where we are interested in the average response of an experimental unit before and after some treatment. So some examples of this to help you wrap your minds around it. Let's say a doctor wants to compare a patient's heart rate before and after treatment with a given drug. Okay? Or let's say we want to compare a person's reaction time before and after drinking 1 ounce of 100 proof alcohol. Okay? Or maybe we want to compare a student's math skills before and after being taught a specific course. Okay, this is what we are going to be doing in this lesson. So, generally, the sample size for a paired difference experimental design is small, and we must take several assumptions for the test to be valid. First of all, the samples are dependent. They are matched pairs, meaning like we are using the same subject for before and after. They are comparing to themselves. Second of all, the matched pairs are a simple random sample. And third of all, the number of pairs of sample data is large, or the differences are from a population that is approximately normally distributed. It has to be normal distribution. So let's talk about the test statistic for this. Okay, the formula for the test statistic looks like this. Now, in the past, all of the test statistics that I've given you, we haven't really had to look at much because I'm like, well, we don't actually have to figure that out. I'm just going to give you a template. For this guy right here, there is not going to be any new templates. Okay? We are using the templates that we already have. But what I need you to pay attention to is the variables that we are going to be working with. First of all, this is going to be a t-distribution. A t-distribution. Just a reminder, t-distribution means we're going to be using degrees of freedom. Okay, there's going to be degrees of freedom. Now, here I have this x bar sub d. Okay, that stands for the mean value of the sample of differences. So x bar is still sample mean, but that sub d there means that we're talking about the sample of differences. The same thing with mu sub d, the mean value of the population of differences. S sub d is the standard deviation of the sample of differences. And then finally, n is just going to be the sample size, okay, just like normal. So let's come down here to number 1. Number 1 says, given 2 dependent random samples with the following results. The first population has a given result, the second population has a given result. Use this data to find the 90% confidence interval for the true difference between the population means. Let D equal population entry 1 minus population entry 2, and assume that both populations are normally distributed. So here's the thing. Part A says, find the mean of the paired differences and round your answer to 1 decimal place. Here's what we need to do. We need to take this table and we need to translate it, okay? So I want you guys to highlight this table, and you're going to copy it, Control C. And then you're going to come down here and you're going to click, but before you paste, remember we're going to go over here and we're going to go to your home bar. You're going to go to Paste, that drop down, and then Paste Special. And then I want you to transpose it. Transpose it. I said translate earlier. I meant transpose. Okay? Now, if this bothers you here where it's like, well, you can wrap the text or whatever you want to make it easier to read, whatever you want. Okay? Now, they want me to find the mean of the paired differences. That is exactly what it sounds like. We are going to be finding the mean of something, and that thing that we're going to find the mean of is called paired differences. Literally means that we want another column here, so I'm going to wrap that, another column here, and that column is going to be labeled differences, okay? And they literally tell you up here how to find the paired differences. Because D stands for difference, let D equals population entry 1 minus population entry 2. So to find the difference, we want to say equals my first population minus my second population. Like they're literally telling you how to find it. Okay? Then you just have to drag it down. Okay? That's the difference between these two populations. So between my first and second population, I went down 4. Then I went down 7. Then I went up 6. So they didn't really give us any context of this problem. So if we were like comparing heart rates, that could be good or bad. Or if we were comparing scores, like your score went down 4 points, your score went down 7 points, or maybe we're comparing weight loss. Like we lost 4 pounds, we lost 7 pounds. So they didn't give us any context to this problem. So like we don't know if these negatives mean good or bad things. But all they want me to do is now find the mean of that. So here's my differences column. You're going to come down here, and you're literally just going to find the average of all of these differences. That's all it is. And then they want you to round to 1 decimal point. So I'm just going to put average there. And again, you can highlight it. What do you guys think? Is that so bad? Now, just so we're all on the same page, this number right here is what we would call x bar sub d. X bar sub d. All right. Part B says find the critical value that should be used in constructing the confidence interval. Round your answer to 3 decimal places. Now just a reminder, critical value is either a t-value or a z-value. With these problems, we're going to be finding the t-value. So to find the critical value, we need a couple of things. First of all, we need to know what confidence interval they want for us. Did they tell us in this problem at all? 90%, good. Way up here it said 90% confidence interval. So my confidence level is 90% or 0.9. And what does that help me find? My alpha is then going to be what? 0.1, very good. And then what does that help me find? My alpha over 2. So what is my alpha over 2? 0.05. Now, to find my critical value, how do we find a t-value? Do you guys remember what I type in? T dot I and B, very good, of, now the probability is my alpha over 2? Is that what it is? Very good. 1 minus my alpha over 2, so 0.05, comma, my degrees of freedom. What was my sample size with these? How many values did they give you in the population? 7. They were 7 values. So what is my degrees of freedom going to be? 6. Very good. So my t-value here is 1.943. They want me to round to 3 decimal places. So I'm going to say t is approximately 1.943. Okay? Now part C, find the standard deviation of the paired differences to be used in constructing the confidence interval. Round your answer to 1 decimal place. Okay, so they want the standard deviation of the paired differences. Guys, right here, this column right here, that is my paired differences. Okay? They want me to find the standard deviation of that. So literally all I'm going to do here is type in equals standard deviation dot S or dot P. Good, this is a sample. Dot S of, and then you're just going to go highlight that column of all of the differences. So from here to here. So standard deviation of minus D59 to D65. And again, they want it rounded to 1 decimal place. So that is going to be my S sub d. Okay? Now, part D, construct the 90% confidence interval and round your answer to 1 decimal place. Guys, I am telling you right here and now, this formula is on your sheet. Okay? This formula is on your sheet. Excuse me. Construct the 90% confidence interval. It's going to look like this. Hypothesis, test statistic, and confidence intervals of paired differences. So first of all, here's the t-value. Here's the t-value that they want you to find. And then here is how to find my confidence interval. Well, if we're going to look at that, the confidence interval starts with what? What is this guy right here? X bar sub d. Well, wait a minute. Do I have my X bar sub d? Yeah, dude. I already know that my X bar sub d is about, or excuse me, what did we say that it was? Negative 1.1? Now, I am not rounding. I know that right now it looks like I am rounding. I am not rounding. I'm just jotting down information so you know what I'm referencing. When I actually put it into the cell, I'm going to use cell references. Excuse me. Then, I need my what? T sub alpha over 2. Do I have my t-value? Yeah, I already said my t-value is approximately 1.943. Right? And then finally, I want my S value. We said my S value is about 6.0. So using this formula, which is on your purple sheet, this guy right here, that's why I found all of these values. That's why I found my X bar. That's why I found my T and my S sub D. Now to find my confidence interval, I want to focus on the margin of error. Okay, now just a reminder, the margin of error is what we are adding and subtracting to the X bar. Okay, so I'm going to do a little cell here, margin of error, and to find that I'm going to take my T times S bar, or excuse me, T times S divided by the square root of N. So I'm going to do a cell reference here, equals, and then I'm going to come right over here, T. So I'm going to click that cell so it does not round. We don't want it to round. Times my S value, again, cell reference, do not round it, do not round it, divided by square root of, and what does N stand for? Sample size, how many were in my sample again? 7, very good. Yes. Now, I found my margin of error. Now what I want to do is add and subtract it to my X bar. So, my interval, there's going to be a lower and an upper. To find my lower, we are going to take my X bar, so equals, you're going to have to come up here and do a cell reference, your X bar minus your margin of error. And I'm going to teach you a trick. So you don't have to scroll so much. What cell was my X bar? D66. So you can come over here for your upper and you can hit equals and you can literally type it in, D66, and it'll do a cell reference for you. Then plus my margin of error. Yes. 1 second. Let me show you how I want this answer written, and then I'll come help. So it says construct a 90% confidence interval. My 90% confidence interval is from negative 5.6 to 3.3. Okay. Now let's go to number 2. An SAT prep course claims to improve the test score of students. The table below shows the scores for 7 students the first 2 times they took the SAT. Before taking the SAT for the second time, each student took a course to try to improve his or her verbal SAT scores. Do these results support the claim that the SAT prep course improves the student's verbal SAT scores? Then they tell you again, let the difference be the verbal SAT scores prior to taking the course minus the SAT scores after taking the course. So you guys have a table right here, and it says use a level of alpha of 0.05 for the test. Assume that the verbal SAT scores are normally distributed for the population of students both before and after taking the SAT prep scores. So what is our sample size here just by looking at this? 7, very good. And they're saying this row right here, this is their score before they took a prep course. Then after they took the SAT, they're like, listen, I might need a little bit of help. This is what they got after they took a prep course, okay? So part A says state the null and alternative hypothesis for the test, okay? So we're going to have to go back to this problem and figure out what are they talking about? What is the information they want to give us here? So what do they think? What are they asking? Yeah, do these results support the claim that the SAT prep course improves the student's verbal SAT scores, right? So we are going to say my null hypothesis here, is that the mean of the difference is actually nothing. Our null is saying that there is no change. Okay, our null is saying that there is no impact. Now, this next part is going to require a little bit of thought process, okay? The alternative hypothesis is that my average difference is going to be less than 0. Now, here's where your brains are going, and I already know it. Your brains are thinking, less than 0, Mrs. Getz, we want to make improvements. Doesn't that mean we want to get better, right? But I want you to think about this. D, they already told me up above that D is going to be my first score minus my second score, right? If I made improvements from this course, which one is going to be bigger, your first score or your second score? Your second score is going to be better. This one, your first score should be a small number, and then you're going to take the prep course, and your second score should be a higher number, so it should be a larger number, right? So when we take the difference, which they told me they want it to be first minus second, if I'm going to take a smaller number minus a larger number, I'm going to get a number that's negative, right? Which means it's less than 0. That means improvement. Okay? And that's very hard to wrap our heads around. So our null hypothesis is that this prep course does not help. There is no change in score based on it. Okay? Our alternative hypothesis is that the mean difference is going to be less than 0. Our mean difference is going to be negative because I want improvement in that score. So my second number has to be larger. All right? Oh gosh, this is stuck. Okay. Now, part B. Find the value of the standard deviation of the paired differences. Round your answer to 1 decimal place. So here's what we're going to do. We're going to copy this table, and we're going to come down here, and I don't know what's happening. And we are going to transpose it. So I'm going to paste, special, transpose. I don't know why it is doing that. Sure it's doing that? Or is it just mine? How do we stop it? I'm having a really great day. Let's see if that helps. There we go. It's a mess, but here we are. Okay. Now, again, if this bothers you, like here it says score on first and score on second, you can come up here and wrap that text, and so it's easier to see. And they want me to find the standard deviation of the paired differences and round your answer to 1 decimal place. So we're going to add another column, differences here. And they told me up above that the differences is going to equal the first test score minus the second test score. We're going to drag that on down. First of all, based on what we talked about, I want you to look at all of the differences. Do you guys see all the differences? Are they all negative? Is that good or bad? That's good. That means they all made improvements. But now what they want me to do is find the value of the standard deviation of all of those guys. So what I'm going to do here is come down here and just say standard deviation dot S or dot P? S, very good. And I'm going to label it standard deviation. Wow. Yeah. Okay. Now, instead of going through that whole process with that formula, what if we use one of our templates? So if I look back at my null and alternative hypothesis, even though mine's a mess right now, can you tell me, is it going to be a one-tailed or two-tailed test? It's going to be a one-tailed test. And is it going to be mean or proportion? Mean. So one-tailed mean, sigma known or sigma unknown? Sigma unknown. So let's go get that template. One-tailed mean, sigma unknown. Now, all of the information that I need for this is already given to me. What did they say the significance level was, the alpha? Yeah, up above they said it was 0.05. Now my x bar, have I found that yet? No, because remember, x bar in this problem is x bar sub d, right? But watch this. I can find that right there in that box. I can go in and type in equals average, and I can highlight those differences, and it's going to find me the x bar. And I don't have to round. What about my mu? What did we say my mu was? 0, very good. Now my S value, remember this is S sub D, just like this is mu sub D. My S value I've already found. So if you want, you can come over here and type it in again, or I'm just going to go equals and do a cell reference. Do not round it, okay? Do not just type in 24.4. That's not what I want. I want the exact. And then my in value. What was my in value we said? 7. And look, they have all of that information. They found my p value. There is my s value. We know my in value. So, that being said, let's go down to part C. Compute the value of the test statistic. Round your answer to 3 decimal places. I already have that from my table. I don't have to compute anything. So equals, I'm just going to come right up here and click on that. And then I'm going to change it to 3 decimal places. Okay. Part D, determine the decision rule for rejecting the null hypothesis. Round the numerical portion of your answer to 3 decimal places. Here's what that means. That means we want the decision rule. That means we are going to reject the null hypothesis if t is what? One-tailed or two-tailed? One-tailed, left-tailed, or right-tailed? Left-tailed, because it's less than, right? So we would look at the critical value. You're absolutely right there, Ryan. We would look at the critical value and we would look at left-tailed. So we would reject the null if t is less than negative 1.943. Then finally, they want me to make the decision for the hypothesis test. So we've already said, you know, here's the decision rule, here's my mean. We want to reject it if it's less than negative 1.943. That's my rejection region. What is my test statistic here? Negative 5.9. So tell me, do I reject or do I fail to reject? Reject the null. If I reject the null, what does that mean? There is sufficient evidence at the 0.05 level. What? To support the claim that the SAT prep course improves the student's verbal SAT scores. And then if you want, if you're like, I can't really read that, you can merge and center and wrap that text so you can see it. Now guys, here's the thing. If I were to give you that table, just the table, and I were to say, okay, here's 7 students. Here's the score on the first SAT, and here's the score on the second SAT. And I tell you, in between those 2 tests, they took a prep course. Do you think it helped? Just by looking at the scores, what would you say? Yeah, you can see that their scores went up. Okay, that's common sense. That's logical thinking. We just showed how to prove it using statistics. We said, okay, well, we can do the one-tailed mean. We found the mean of the differences. We found the standard deviation of the differences. We put it in, and we see that it's in the rejection region, so we reject the null, which means there is enough evidence to state that this does help. All right.